Okay, so for this video, we're going to talk about two-way Anova with Excel. So this presentation will be focusing on two-way Anova with replication. Okay, so in our previous video, we've talked about one-way Anova with Excel. So in here, we're going to focus on two-way Anova with replication because there's also two-way Anova without replication. So use two-way ANOVA to assess differences between the group means that are defined by two categorical factors. Okay, so there are two categorical factors. In this post, we'll work through two-way ANOVA using Excel. Even if Excel isn't your main statistical package, this post is an excellent introduction to two-way ANOVA. Excel refers to analysis. So basically, the process will be more likely or close enough to our previous video about one-way ANOVA. So the only differ from this presentation from two-way ANOVA to one-way ANOVA is one-way ANOVA. Only consider one factor, one categorical factor. But in here, we're going to consider two categorical factor. Okay. So we're going to provide a step-by-step presentation using the Microsoft Excel in here and also, but before anything else, you need to make sure your data analysis is already added to your Microsoft Excel. So first you're going to go to file and then check on the add-ins and then import the data analysis tool pack plug add-ins. Okay. So let's focus on two-way ANOVA in Excel. To perform this analysis, you'll need to have two categorical variables, as I said, which analyst also refers to as factors. So these two categorical variables are also known as categorical factors, okay? These factors are your independent variables. As usual, we're going to have one dependent variable which is not a categorical but a number or ratio or interval. Okay? The number of factors in your analysis determines the name of ANOVA analysis. So for one-way ANOVA, you are going to use one factor. Two-way ANOVA, we're going to use two factor, of course. Each factor has a finite number of possible values, which are known as levels. For example, gender is a categorical factor and has the two levels, male and female. Another categorical factor you can have is maybe your marital status. So that is single, married, or separated, widow, something like that. You also need one continuous outcome variable, and that is our dependent variable. The various combination of values for two categorical variable divide the continuous data into groups. Two-way ANOVA determines whether the mean differences between these groups are statistically significant. Okay. So two-way ANOVA determines whether the interaction effect between the two factors is statistically significant. So in here we're going to have the two-way ANOVA with interaction. And then there's also like two-way ANOVA without interaction. Okay. When significant interaction effects are present, it's crucial to interpret them correctly. So basically, when talking about the with interaction, the problem itself, we're going to state na nana siya interaction or wala. Okay? Because they can be tricky to understand, I'll spend a little extra time covering the interaction effects. Okay, I'll run through two samples to explain the differences between cases where the interaction effects is and is not significant. So there's this data set. Okay, next slide. So here we have here the ANOVA single factor, ANOVA two factor with replication, and then we also have ANOVA two factor without replication. So you can have two factor without replication but with interaction, or you can have two factor with replication and then with interaction, something like that, the idea. Replication in this context refers to collecting multiple observations for each group. For instance, in a first analysis example, in this post, we'll look at gender and college major to determine whether these factors correspond to statistically significant income differences we will collect only one observation per group. One female who majors in statistics would use the without replication. But, however, that produces a tiny sample size. Therefore, we'll use a with replication option so we can have a multiple observation per group. For both the examples, we'll have 20 observations per group. Oh, that's a lot. That example is from the dataset that we're supposed to download, but I didn't have the link in here, okay? But that's okay, I'm going to give you another example later on my next video. So, example of two-way ANOVA without significant interaction is, so imagine we are assessing annual salaries, so which is our continuous dependent variable. Our two categorical factors is gender and college major for analysis. We'll use three major statistics: psychology, pulsi, statistics, psychology, and pulsi. Combination of these factors is the two gender, which is male and female. So we have three groups for the majors and then two group for gender, male and female. So this can be the sample. So for male statistics, it has that income. Male psychology, it has that income. So the dollars amount indicated the average income for each group. Two-way ANOVA determines whether the observation differences between the mean provide strong evidence to conclude that the population means are different. Okay. So here are the steps. First, we're going to click the analysis. So same concept on our usual thing that we do. We click on data analysis, and then the data analysis, go click on the ANOVA, and then we're going to input the data in which input the cell, identify the cell in which data are in, and then we're going to set the alpha and or the level of significance, and then we just click OK. So it looks like this, and the result will looks like this. Okay, so it has a lot of table. You're going to interpret or to mention or all this table in your interpretation. So for the first table, first three table, it's going to talk about the descriptive statistics, and then for the last table, as usual, it is the ANOVA table. So when talking about two-way analysis of variance manggod is duha pod ang imuhang null hypothesis ani, two-way man siya. So imo i-consider kung na by significant difference ang first factor, and then na by significant difference ang second factor. So you're going to have two null hypothesis and two alternative hypothesis, okay? And then since naman na siya interaction, so you're going to have an interaction, another hypothesis. So daghan kay kag i-conclude ani guys. So, and also for your ANOVA table, you're going to have three p-value. That is for gender, the first, for columns, which is the measure, and then for interaction. Okay. So first look at this p-value in column ANOVA of variation. But the concept here is kapag ang p-value is less than the alpha, we reject the null hypothesis. So ninana ang idea guys. Tagsa-tagsaon na mo siya conclude para di ka malibog. Okay. So I let you read that one. So let's go back to the table, okay? So let's just focus here. I'm going to zoom in. I'm going to focus on the p-value here. As you can see, the p-value is in negative 0.6. That means that is in exponential form, or ang ihang number dyan na may mo siyang 0.00000, that is very small, okay? So 1 point with exponential of negative 0.6 that is exponential. That means that is less than 0.05, which is our alpha. That means we reject the null hypothesis, saying that there is no significant difference among the gender, male and female. And then for the columns or the measure, that is still very small. That means less than 0.05 or the alpha. That means we're going to reject the null hypothesis, and we're going to conclude that there is a significant difference among the measure or the courses like statistics, psychology, and pulse. Okay, but for the interaction that is not less than 0.05, so that that means that there is no significant interaction among the two variables. Among the two factors. Okay, that is not less than 0.05, so there is no significant that is not significant. So there is no, we're not going to reject the null hypothesis and conclude that there is no significant interaction among the two factors. Okay. So that is how you're going to conclude that one. Anyway, I'm going to have like conceptual interpretation on our Microsoft Excel later on my next video maybe. So let's proceed. So here is an example of interaction or interpretation. Okay. You can refer this explanation on your analysis later for our activity. Okay, next is the summary table information. So the summary table in the top portion displays the mean incomes of 6 groups, as I said. You're going to slightly copy this interpretation or the format, okay? Because when talking about interpretation man you need to mention the entire table. Kung sa itong mga information nga naa diya naka-present, imo na siyang i-mention, imo i-discuss. Then ana na siya ka mag-interpret ka og table. Okay? This means range from a low of 55, okay? And female pulsi measures of high for male statistics measures. Our sample means are different. Importantly, the significant p-value indicate so mentioned already the p-value, and the p-value here is the most important number that we're gonna need to have a conclusion or to create our conclusion for our problem. Overall, male tends to have higher average income across the measures. Additionally, statistics measures tend to have a largest average salary. That's interesting. If you had obtained insignificant p-values, the sample difference between two groups might represent random sampling error rather than differences between the population. Okay. And here is the Anova, two-way Anova example with interaction. So, kanisha. In a previous example, the interaction effect is not significant. Consequently, it is simple matter of interpretation and the main effects. So, how do you understand interaction effects? So, more nag-interact siya ba? Na siya interaction and two-factor like the gender and the major or course. To emphasize how this effect works, I'll use an intentionally silly example to make it more intuitive. Imagine that we're performing a taste test and the dependent variable is enjoyment. One or two factors are food and condiments. We want to determine which condiments procedures the most enjoyment. To keep this thing simple, we'll include only two foods, ice cream and hot dogs, and two condiments. Okay, so this is the example, his example. And as usual, the steps in doing the hypothesis. So, for this example, ano siya hidden data ha? Ano siya hidden data nga show. Anyway, I'm going to show you another example, another situation later. So, two-factor with replication, this one. And then, notice on our p-value. Look at the p-value. 0. I'm going to zoom in for the p-value directly because these are the most important. So, as you can see, for food, 0.8, that means not significant. So, we fail to reject the null hypothesis. So, there is no significant difference about the food. For the condiments, that is less than. So, there is a significant difference for the condiments. And also for the interaction, that is very less than the alpha. That means the interaction of these two is significant. Okay? So for the interpretation, you can say it this way. First, look at the p-value column in Anova source of variation table at the bottom of the output. And then the p-values so these are the main effects. The significance of condiments suggests that a portion of relationship between condiments and enjoyment does not change based on the value and the other independent variable. However, the extremely low p-value of interaction effect is also statistically significant. In general, interaction effects indicate that the relationship between an independent variable and dependent variable changes based on the value of another variable. So that is the explanation on the interaction thing for these factors, okay? For our ANOVA model, the significant interaction indicates that the relationship between condiments and enjoyments depends on the type of food. That makes sense when you think about it. You might like chocolate sauce quite a bit, but I bet you'd find it disgusting on hot dogs, okay? So that is the concept. Naa siya'y interaction. Magdepende siya. Okay. Okay, next slide. So interaction effects and depth. I want you to read this one more. Okay. I'm going to let you read this one. As usual, what are the things that Excel does not include? So while it's fantastic that Excel allows you to perform two-way ANOVA, it doesn't have all the features a full-blown statistics package provides. As mentioned, easiest way to understand interaction effect by using interaction plots. So there is no plots or there is no interaction plots. Unfortunately, Excel can't create them. Excel can analyze only balanced design if your groups have an equal number of observation. Okay. As I said, mag-interaction ra ka kung gimension sa problem, okay? And then kung ang idea niya, ang concept niya, ay kung gusto jud may balance sa problem, ana na siya. And then also here, we have the post talk as I mentioned in my previous video. Post talk is used to determine kung asa jud ato nila ang minglahi ang mean. Okay? And then we have here another residual plots. Muna siya ang mga kakulangon sa Microsoft Excel which is provided by some other statistical software like SPSS. Okay, so for my next video, I'm going to give you the step-by-step process in doing Microsoft Excel na jud with our actual example problem. Okay, so hopefully this helps. And that's all for this video. Have a great day. See you in my next video.